then only we will be able to build the machine learning model. So today we started the session with Analytics Vidhya HR analytics thing, HR analytics data set where we worked earlier. We found out the missing values in the train data set and the test data set. Same variables in both train and test are missing values. Then for pre-processing, I have added the test data into the test data dependent variable with the word test. And now we are concatenating both the data frames, HR train, HR test, axis is equal to 0, row-wise concatenation. Guys, all of you are able to do, or do you need any help from my side?
Sir, we are creating a separate column of is promoted, sir, in test.
Yes, exactly. Because that column is not there in the test data. Actually, we have to predict that column using the train dataset model.
Sir, in train data, there are 16 variables and in test data, there are only 13, sir. Can it concat like that?
No, there cannot be 16 and 13. How can there be 16 and 13?
Sir, I just now saw the shape, sir.
1 second. Print HR train.
Sir, is promoted bins and service bins are missing.
HR test. Acha, 16 and 14. Okay. All right. Oh, we had a problem here. Okay. We have created some bins, right? Last time?
Yes, sir.
Okay. So what we will do is, sorry, that's a mistake. So let us import the data again. Okay. To avoid the problem, so re-import train data as the earlier data had new variables. Okay, so I'll go to the top and I'll copy paste that command HR train read.csv. Thank you. I've noticed it. Otherwise, would have been wasted time, lot of time. Similarly, HR test. I'll copy the HR test. Control C. Now I'll move this below this. 14 and 13, right?
Hello, good morning, sir.
Yeah.
Hello.
Yeah, good morning. Tell me.
Sir, am I audible, sir?
Yeah, yes, you are audible.
Sir, please explain that libraries, sir, pandas and numpy. We don't have any idea about that, sir. And the functions where to use at what functions. You are using here HR test equal to PD. Why can't we use NP, sir, here?
Because I told you, what's your name?
Sir, Mohammad Mujib, sir.
See, you missed the
I was absent in the first class.
That's the problem. So in the first class, a detailed description was given here. See here, you have to go through the video. See here, everything was explained in the first session. What is pandas data frame? What is the function syntax? Everything is there in that video. I would suggest go through the video in detail. It's there in the Google Drive. right? The function syntax, the data frame syntax, everything was clearly explained. Why we are using what functions, I am telling you at each point of time. What you call, whenever I use a function, I am telling you, right? I am writing it, in fact, not telling you. So you have to go to the first video. The first video we have dealt in detail what is pandas, what is NumPy, and what is matplotlib, what are the sub packages, everything is there. You have to go through that video.
Okay.
What is the function syntax? Why should we use pd.read underscore CSV? See here. Library name dot function name. PD is the pandas library, read underscore CSV is a predefined function. Every function in center must have parentheses. So everything has been, what you are asking has been discussed in session 1 video. Other participants know this, right?
Sorry,
Other participants know this because you have to go to the first video.
no one knows, sir. Just ask Rishabh also don't know, Vikram, they don't know.
They don't know why.
Yeah. We were absent in the first class also, sir. We are not getting this, when to use these functions.
See, the function names are like your, see, usage is being given. So libraries and this thing, what I would suggest is go through the video first. We will discuss them in the Monday session. Whatever doubts you have, I will clarify them on the Monday session. Because what is happening here is you have to go through the session video if you missed it. Otherwise, it will be the same problem again and again. Or you have to attend every session without missing. This is clearly given. Every session, every library is clearly defined. Every library's function has been defined. So pandas has the import functions. NumPy does not have the import functions. NumPy does not have info. By this time, you should have realized what is pandas and what is NumPy. You have attended 3-4 sessions. You should have realized what is pandas and what is NumPy. Because I have not used any NumPy function till now. Have I used any NumPy function? Maybe for what you call in the hypothesis testing of the this one np.min, I might have used it. But everything is clear cut in terms of the library name and the function name. All the functions which we are dealing with is related to pandas library, and every function read underscore CSV. What does read underscore CSV mean? The name itself says you have to import the file. Read in programming is importing file. To in program is exporting the file. So read is read underscore CSV. The function name itself will tell you what you are doing. Read underscore CSV means you are importing the CSV file. And I have given you very detailed description of each functions. Shape will give you number of rows and number of columns. D types will give you individual variable D types. Variable names you get in df.columns.
What DF will do, sir? You have
What
written A or B and DF. What it
That's
means,
the name
sir?
I have given. That's the
Okay.
name I have given. It's a name, boss. Wow, there is nothing that it's a name. How did I import the data frame here? I imported it with the name Airbnb DF. See, how did I name the data frame? The basic name I have given is Airbnb DF. See, you have to go through the video and you have to follow the session. Every session I am explaining you the functions very clearly, which functions to use. This is a function-based programming language like Excel. Okay, so you have to understand, and the function names are decided based on its utility or purpose. What the purpose is there, that based on it, the functions names are given. And some of you are getting confused between keywords and functions. Keywords are programming codes. This is not Python programming course. This is Python for data science. Programming keywords are different. You have to be, these are functions which I have clearly specified in the first session only, that everything is function oriented programming is Python. Which is designed in such a way that a non-programming, non-engineer guy can also use it. And that's why we have this function-based programming where we have functions, and I have written everything, what function means what. You have to just go through the video. Once you have gone through the video, you have any doubts, you ask me, I'll clarify it on the Monday session. Is it clear? I have given detailed notes here.
Sir, I
Yes,
have an Yes, sir, I have an error to import files. Sir, I can give you the AnyDesk ID.
Give me the AnyDesk ID. What is the error you are getting?
Okay. Sir,
Yeah.
AnyDesk. So my AnyDesk ID is 441908970. 441.
Accept the connection request.
Okay, sir. Hello.
Yes.
Yes, sir. Accept हो गया. So this is the error to import IO.
What is the train data file?
So ये error आ रहा है sir. Oh, dot CSV. I forget the dot CSV file. Thank you, sir. Hello.
Yeah, it's done.
Thank you, sir.
Yeah. So we have imported the data sets. We have done the shape function to see the variable counts. We have found out that the variables are not matching. So we have added the test variable, dependent variable to the test data. We got 14 and 13. Now we are concatenating. Concatenating is row-wise combining of data. Concatenation means combining the data into one data frame. All right, can we move forward? Yeah, can participants confirm? Should we move forward?
Yes, sir.
Okay. So combine df dot shape. So 78,298 observations with 14 variables. So we have 78,298 observations with 14 variables. So combine df dot education dot value underscore counts drop na is equal to false. So value underscore counts is the function for frequencies. Frequency counts. So in the education variable, we have 3,443 missing values. So what should we do with them? We have bachelor's, master's, and below secondary, and not NaN is not a number, which is missing value. We have 3,443 missing values. So what should we do with them, participants?
We can add a, we can replace it by missing or something.
See, the replacement with missing happens when you have very large missing values. Here, the total amount of missing values, which is how much is the total amount of missing values? 3,443 divided by 78,298. Hardly 4% are the missing values, right? If you check the notes, which I have given as last time for missing values,
Mhm.
when will you use the word missing?
If
When you have, see here. If the variables have greater than 70% missing values, then impute with the word missing.
missing.
So do we have greater than 70% missing values here?
No, sir.
We don't have, right? We don't have greater than 70% missing values here. We
Mhm.
have only how much missing values? 4% missing values. Now, already bachelor's is a very large segment, right? Bachelor's, there's a huge difference between bachelor's and master's, which is around 31,000, right? By adding this 3,443 missing values with the word bachelor's, will it make any difference?
No.
No. So here we will impute the missing values in education variable with the word bachelor's. because missing NAs are only 4.3% or 4.4%, and already bachelors is a very, very large segment, and already bachelors is a very large segment. So by adding this 3,000 to the existing bachelor segment will not affect our data. So that is why there will be no effect on data pattern or trend. So the data trend will not change because already there's a huge difference. So combined DF dot education is equal to combined DF dot education dot fill NA double quotes, copy and paste the name from here, Control C, bachelors. We are filling the missing value with the word which bachelors, and I am going back and running the code again. Now bachelors have become 55,690. So the imputation of variable with bachelors is done because that's a missing values are hardly 4.4%. By adding this 3,000 observations to the bachelor segment, the data pattern will not change because already bachelors is a very huge segment in the data. There is a huge difference of 31,000 observations already between the first bachelors and the masters and above. Clear, participants? Why we have used bachelors as the missing value imputation here?
Yes, sir.
So combine DF dot previous year rating dot value underscore counts. Drop NA is equal to false. Again, we are trying to get the frequency of the categorizations. 1 rating, 2 rating, 3, 4, and 5, and missing values are 5,936. So what should we do here, participants?
So we can impute it with 3.
Yeah, we can impute with 3 because the same logic. Already there is a huge difference between 3 rating and 5 rating, right? Almost 10,000 observations. So by adding this 5,000 observations to the 3 rating will not affect us, and 3 rating is average rating in any organization. So that will not affect our data pattern. So the data pattern is not affected by simply adding it to the 3. So we will replace the missing value with 3. So combine DF dot education is it, sorry, previous year rating, sorry, is equal to combine DF dot previous year rating dot fill NA 3.0. So we have run the previous command. Now we can see the previous command. The missing values are gone.
So would it cause a issue if I put 3.0 in double quotes? Or
You can put it in, you can put it in double quotes also. It will not cause any issue.
okay.
But what happens is we have to check other type also. The other will be definitely integer only. You'll have integer and object. Ultimately, it will take it as object data only. In this case, it will not cause any problem.
Okay.
But in some instances where it might cause a problem. If
Understood.
dot zero is not there. We are inputting with 3 rating as it is the largest segment, and missing values are few. Missing values are few. All right, participants, shall we move forward?
Yes, sir.
So we have treated the missing values. We have treated the missing values in our data in the 2 variables. Now we will go to the next process of label encoding or dummy variable encoding. Label encoding or dummy variable encoding is assigning numerical identifiers to the text data or non-numeric categorical data. For this purpose, for dummy encoding, we must split or label encoding we must split data into numeric and object columns. Numeric columns and object columns. So numeric calls is equal to combine df dot select underscore d types. So we will select the d types np dot number. include is equal to np dot number. So select underscore d types is for selecting the columns or variables based on data types. Select underscore d types function will select based on the data type you specified in the brackets. Here we are specifying the data type as number. So np dot number will take both int64 and float 64, and np dot number will consider both float 64 and int 64, and will separate those variables into a separate data frame called numeric calls. Similarly, object calls is equal to combine df dot select underscore d types include is equal to square bracket single quote object. So this will take the object columns as the separate data point. So you can see here we have split the data into two data types. Print numeric calls dot shape, print object calls dot shape. So total variables we have 14. So we have 8 numeric columns, we have 6 object columns. So our data frame we split into two now, which is one data frame of numeric columns and then the second data frame of object columns.
Sir, if there is a date, then where we should?
Date, see, date is a variable from which we will extract information like year, month. So date is a different type of analysis. We call it as time series analysis. So when you have date, time or date in the variables, generally we extract information from date like weekday, month, year, like that, and then we'll delete the date. If there are two dates, like let us say loan applied date and loan approved date, then we'll calculate the difference between two dates and we'll delete the date columns. Now, date columns will not be directly included into the models. So what happens is when you are pre-processing the data, particularly when you have date columns, when you extract the week, weekday, month and year, it becomes integers, int64s. So they will come under numerical columns. Then we will move them from numeric columns to object columns because we can't treat them as numbers. Now, if you have two dates in your data, we will calculate the difference of the dates. Then it will become a numerical data. Then you will delete the date columns. Or if you want date has to be included in your analysis, then it becomes a time series data analysis for which we have different set of algorithms and different types of pre-processing also. For time series data, we don't do this missing value imputation like this, mean imputation. In time series data, we have imputations like backward fill, forward fill, like that we will have. We don't do mean imputation. We use backward filling or forward filling. That means you fill the missing value with the previous value, or you fill the missing value with the next value. So that sort of analysis will be there. So date times we don't use in our analysis. We extract information from them and then we'll delete them.
Okay,
it?
sir.
Yeah.
Got it, sir.
Yeah. So date time has to be, it depends on the type of data you are analysis you are doing.
Okay, sir.
Now, numeric calls dot columns. Now we have to identify So one of the problem you have to understand in numeric columns is all numeric data will not be numeric. They might be representing categories. They might be representing categories. Take for example, the variable previous year rating. We have previous year rating, right? 1, 2, 3, 4, 5. So we can't treat them as numbers. We have to treat them as categories. Rating 1, rating 2, rating 3, like that. So we have previous year rating from 1 to 5. Similarly, we have variables like KPIs met. This is 0 and 1. KPIs met and awards 1. These variables are in the form of 0 and 1. 0 means no and 1 means yes, right? So these sort of variables which come in numeric variables, you can look at them. They will be what you call categorical data, but since they are understood as int64, they will come as numeric data. Take for example, combine df dot or square bracket single quote KPIs met greater than 80% dot value underscore counts. See, 0 is 50,578, 1 is 27,720. So we have 0 and 1. 0 represents no, 1 represents yes. Same thing with awards 1. So combine df square bracket awards 1 dot value underscore counts, again 0 and 1. So when you have these sort of variables, we have to move them from non-numeric variables to object variables. And then we have to delete them from, sorry, if I used numeric here, you should use numeric calls, right? Not combined df, numeric calls. So these three variables, previous year rating, KPIs met, awards 1, they have to be added to the object columns. And then we have to delete them from the numeric columns. So object calls, square bracket, single quote, previous year rating is equal to numeric calls dot previous year rating. Similarly, object calls, square bracket, single quote, KPI is met 80% is equal to numeric calls, square bracket, single quote, KPI is met 80%. Object calls, square bracket, single quote, awards 1 is equal to numeric calls, square bracket, single quote, awards 1. We will add it to the object calls. Then we will drop them to the numeric calls. We will add categorical calls from numeric calls to object calls. Then we will drop categorical calls from numeric calls so that there is no duplication of data. So numeric calls is equal to numeric calls dot drop open bracket square bracket previous year rating comma KPIs met comma awards 1 comma axis is equal to 1. Axis is equal to 1 is column dropping. Axis is equal to 1 is axis is equal to 1 is column dropping. You drop these columns.
Sir,
Yeah.
sir, whenever we need to drop, we need to first convert into object also, sir.
No, 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 no. No need, no need. See the purpose. See that you are not understanding here. Within the numeric columns, we have certain columns which are non-numeric in nature, like KPIs met and awards 1. They are 0 and 1s. And previous year rating, which is rating scales. These cannot be treated as what we call as numeric columns. These have to be treated as object columns. So we are moving them to object columns first, and then we are dropping them. You can directly drop numeric calls and directly drop object calls directly. You don't need to convert them into other data type. You can directly drop them using the drop function. Here, what we are doing is we are moving from numerical variables to object variables because they are actually object variables, but because of their values being zeros and ones, they are being taken as numeric data, but we should not treat them as numeric data. We should always treat them as categories. We are moving them into object calls, and then we are deleting from numeric calls. That is the process which I have done here. So if you look at the shapes again, we will see that object calls have increased to 9 and numeric calls have decreased to 5. See, object calls are 9. The total is 14 only, it didn't change, but we have moved 3 numeric columns into object columns because they are categorical in nature. 3 numeric calls have to be moved to be object calls because they are in categorical in nature. All right, participants, any doubts? Okay, can you move forward, participants?
Yes, sir.
Now we will start the process of label encoding. See, object calls dot head. Three rows. This is our data. See, this is our data, which is in text, and some of them are in numbers, text and numbers. Now we have to convert them into categorical data. So from sklearn dot pre-processing import label encoder. LE is equal to label encoder null braces.
Sir, I have a doubt.
Yeah, please.
Sir, now is promoted is either 0 or 1, right? So why did it in the beginning itself go into object?
Because it is zeros and ones are integers, right?
Yeah, but you should go to a num call, right? Like numeric calls. Why did
Yeah,
it go?
that's what. We have moved them, na?
No, is promoted. We haven't moved, sir. Like because
Which one?
it already moved to. object.
So is promoted is because half of the is promoted is test value, right?
Oh yeah.
We have, it's a mixed type.
Yeah.
It's a mixed type. So when you have mixed type of num and object, it will take, by default, it will take it as object. So
Okay.
is promoted test has test words are there, na? So that is
Yes,
why
yes,
it's
yes.
coming here.
Yes, sir. Yeah. I
So
remember
that you reminded me. Good, good. We have to move that to numeric calls.
Sir, can you show the drop command? Yes.
We have to move the. You have reminded me correctly. Numeric calls dot is underscore quote is underscore promoted is equal to object calls dot is underscore promoted. Then we'll drop it. Object calls. We will label encode it later.
So, but how does like it's a true like text is a test value is a string, right? So how does it go in? Like, okay, yeah. Understood.
Trust is
Sure.
string is object here, right?
Mhm.
So we are dropping it from object calls. So we have 6 numeric calls and 8 object calls. We will label encode is promoted separately. Done, participants, all of you?
Yes, sir.
Now, let us start the label encoding process. Object calls dummy is equal to object calls dot apply. The function is le dot fit underscore transform. So fit underscore transform is a function predefined to convert text into numbers. How it assigns numbers is based on alphabetical order. The text values will be assigned numbers in alphabetical order from 0. So if you look at object calls dummy dot head 3, you can see we have converted everything to numbers. So the rating scale, it will assign numerical identifiers to text data as well as the numerical categorical data in alphabetical order or in numerical order starting from 0. Starting from 0. So we see here the department is now 747, region is 31, 14 and 10, education is 200, gender is 011. So it is assigning numerical identifiers to the text data. This process we call it as dummy variable encoding, also called as label encoding. This process must be done because if there is any text data or object data in your data frame, you cannot run machine learning algorithms. It will simply say string found or object data found, model cannot be implemented. So it will give you a big error saying that string found and model failed. So we have to convert all the values into categories or dummy encoded values. Dummy encoded values are values which start from 0. They start from alphabetical order if it is a categorical text value, and it will start with the smallest number in ascending order if it is numerical value.
Sir,
Yeah.
when you want to convert into text or objects, what the function we have to use? You convert it into numerical, no?
There is a function called inverse transform. Whatever we got. Y contains previously unseen labels 2, 3, 4, 5, 6, 7, 8. Okay. It is giving us error. Earlier it used to apply, used to do with inverse transform. So fit underscore transform will convert it. Inverse underscore transform will inverse it or re-get it back. They might have changed some format. A long one. Okay, le dot fit underscore call. Mhm. They've changed the function format. Let me just check once. Yes. I think inverse transform, it is creating a problem here. Encoders, label encoder, encoders no transform I. Okay. Or let us see le dot classes should work. I think inverse transform le dot inverse transform calls dummy dot department. What is happening? Previously unseen labels are coming. Why it is coming like this? Let me just check now. One more time documentation. I'll get back to you next session. Okay. Just let me so inverse transform Acha, list. Okay, we have used list function. Huh? Let's try list. It calls dummy department. Oh, this function is also giving error. Previously unknown labels. Then what is the solution? Earlier we used to get it. I don't know why they changed this in the current edition. With underscore list used to work. Data dot square bracket, right? It's not working. Let us say if I change it to single quote depart. No. Acha, I think we have to do it the other way. Okay. Object calls dummy is equal to le dot sorry. Let me redefine object calls one more time. Object calls, then run all the commands. Okay. le dot with underscore transform object calls. Array. Okay. So this data frame structure is causing the problem. So object calls dot apply le dot with underscore transform, and we got the values. So actually they changed the structure actually. So that is why we are not getting it. But earlier it used to work. We used to just simply inverse transform. See encoder dot inverse transform and data, but I don't know this version they changed. Let me check the documentation once. Okay, I'll get back to you. There will be something in the documentation where they might have given the process to convert it back. So we have converted the dummies. Now we will concat the data frame into one. Concat both data frames, which is numerical and object, into one. So combine df underscore clean is equal to pd dot concat square bracket numeric calls comma object calls dummy comma axis is equal to 1. Here we are doing column wise concatenation. We are doing column wise concatenation. So first paste all the columns of numeric calls. Next to it, it will paste all the columns of object calls. So our data is now ready. Our data is now ready. We can split it back to train data frame. And test data. So HR train df is equal to, I'm giving it a new name, combine df underscore clean, square bracket, combine df underscore clean dot is underscore promoted not equal to test. Similarly, HR test df is equal to combine df underscore clean, square bracket, combine df underscore clean dot is underscore promoted double equals to test. So we are splitting the data. HR test df is equal to HR test df dot drop is underscore promoted comma axis is equal to 1. So we have dropped the column which we have created initially to merge the data frames or concat the data frames, that we have dropped. Now we have, after we have completed the pre-processing and we have brought the data back to the normal shape.
Sir, can you please explain once again, split back the train data and test data?
So we have earlier merged the train data and test data for the purpose of pre-processing. Now, when you are doing pre-processing, you should implement the same strategy what you have implemented on train data. Same strategy must be implemented on the test data. If there is a difference in strategy, then it will throw up errors. Now, to avoid this problem, we generally merge the data frames into one. We merge the train data frames and test data frames to one. Now, since the test data frame will not have the dependent variable, we will add the dependent variable to the test data. Then we will concat both the train data and test data. Then we will do the missing value imputations. Then we will do the splitting of data into object calls and numeric calls. Then we identify the categorical calls in the numeric calls and move them to object calls. Then we will drop those categorical calls from numeric calls. Then we will label encode object columns. Once we have label encoded object columns, we concat them both column wise. We first paste all the columns of numeric data. Next to it, we will paste all the columns of object data. And once we have the cleaned data frame, now we have to split it back to the original status of HR train and HR test. So I will use is underscore promoted not equal to test. You remember we have added the is underscore promoted column to the test data and filled the column with the word test.
Yes, sir.
So we are using that as the conditional statement here. Not if the cell is not equal to test, treat it as train data. If the cell is equal to test, treat it as test data.
Okay.
And
Got
then
it, sir.
we are dropping the test data. The is promoted, which we have used for conditional for statement, we are dropping it from test data.
Okay, sir.
Okay. So this is the process of data pre-processing. Now we can build any machine learning model on this data. Now, once we have cleaned the data, we can build any machine learning model on this data. This is the process we have to follow every time you get a data, right? All the participants, you need to follow this process every time you get the data. Got it? All right, participants, all of you got this?
Yes, sir.
Oh, membership is ended. Huh? Okay, I'll renew it. Okay, so we have done the pre-processing. I think let's take a break and then we'll continue after the break. Okay, guys. I've already sent to the Melbourne housing data set. We'll work on that.
Okay, sir.
Okay, so we'll break for 15 minutes. Data analysis. Exploratory data analysis, which we call it as EDA. Pandas library is the core, is done using Pandas library. So Pandas library is the core library for data frame based operation. Data frame means table. In Excel, we call it as table. Most of the time, the CSV files are nothing but data tables. CSV files are nothing but data tables. So we have other types of data also, streaming data, unstructured data, sensor based data. They will be in a different format. But when you import the data from a database in a CSV file, it will be in the form of a data table. So this Pandas library is all about data frame based operations. If you go to Google and type Pandas, you will see there are a lot of functions related to these things. You can see the user guide. So Pandas has input output tools or import export tools. It has the, sorry, not tools, functions. Import export functions, indexing and selecting data functions, merging, join, concatenate functions, reshaping pivot table functions, working with text data, working with missing data, duplicates, categoricals, chart visualizations, table visualizations, computational tools, time series data, time functionalities. So these are all broad concepts. Within this, there are a lot of functions. Take, for example, indexing and selecting data. Within this section, you have lots of functions. Dot loc, dot iloc, okay, series, frame. So there are many functions which are there in this library. So the Pandas library has functions related to import / export data, descriptive statistics functions, descriptive statistics functions. Then it has functions related to reshaping the data, resampling the data, splitting the data, collecting data. There are many functions, thousands of functions are there within this Pandas library, which are predefined for doing these activities. So Pandas is the library that we use for exploratory data analysis. We have all the functions related to EDA. And what is EDA? EDA includes descriptive statistics, data visualization, and data aggregation. All these functions are available in Pandas library. So pandas is for exploratory data analysis as well as for reshaping the data. If you have any sort of reshaping or restructuring of data, that will be done by pandas. Matplotlib.pyplot. This is the library for data visualization. This is a data library for visualization, particularly used for adjusting plot windows, adjust the plot windows, size of the plot windows, size of charts, legend fonts, color codings, all those things which you do in what we call visualization, what we call it as visualization features, that can be done using this matplotlib library. After matplotlib library, we have the core library of Python called NumPy, which is the array based or list based computational library, which is used for complex calculations and computations like algorithms. So when you want to run any algorithm or anything, we need this NumPy library. NumPy is the heart of the Python. It runs the calculations and the algorithms. So pandas will restructure the data and bring the data to a form where we can build the algorithm. So what we have done till now, we have used only the pandas libraries to restructure the data, clean the data, restructure the data, and then we brought it right to the form where we can run a machine learning algorithm. Now, where these machine learning algorithms will lie, they will lie in this NumPy library. So within NumPy library, there are certain sub-libraries that are there, which are very important, which will be imported once we import NumPy. So the sub-libraries in NumPy, which will be imported automatically, is scipy.stats for statistics. Similarly, stats models for IoT data or time series data. And the most important which we are concerned with, sklearn, also called as scikit-learn. This is the core library for machine learning in Python. Machine learning in Python, the library is sklearn or scikit-learn. So similarly, this documentation of NumPy is very, very large. The documentation of NumPy is very, very large. And it is, you have to have internet to access the NumPy library. And NumPy has very wide utilities. It is used with lot of functionalities. You can see here, it is used in quantum computing, statistical computing, signal processing, image processing. So there are thousands of libraries within the NumPy library that help you to do these processes, psychological processes, your Bayesian information, bioinformatics. So it has a huge number of libraries in NumPy, which will help you to do lot of these activities: quantum computing, statistical computing, image processing, astronomy, psychology, bioinformatics, mathematics, chemistry, geoscience. All the libraries which have the functions required to do these subjective or these analyses will be there in NumPy. Similarly, within NumPy, we also have something called sklearn. So sklearn is the core library for machine learning in Python. This is like the machine learning part of Python, where you have the classification algorithms, regression algorithms, the clustering algorithms, dimensionality reduction algorithms, model selection algorithms, and the pre-processing activities. So all the activities that are required for building machine learning models, they are all available in sklearn or scikit-learn. So sklearn is the machine learning library of Python. Similarly, we have other libraries also. NLTK and TextBlob are the two libraries for natural language processing. Text. For natural language processing, we have NLTK, TextBlob. TensorFlow, Keras. This is for deep learning image processing. Deep learning and image processing. This is the Core library. So these are the important libraries which will work during our curriculum. During our course, we will work on these libraries, and we will also work on some additional libraries during our course. Now, this is the library which we are introduction to the libraries. The Pandas library is for data structures, data frame based operations, data reshaping, data restructuring, data pre-processing. Once you have done the data pre-processing and data restructuring and you bring it to the form where you are ready to build the machine learning models, then the sklearn library, which is part of the NumPy library, will be used to build machine learning models and to use those models for predictive analysis. The purpose of machine learning is to build models for predictions. Using those models, we will predict. So the sklearn library is the machine learning library, which will have all the algorithms which we are going to study in our curriculum. So till now we have completed till data pre-processing. From Monday session onwards, we will start with algorithms. Now this is the introduction to the library. Now one more thing you need to understand is the function syntax. Now predefined functions are there in Python for running complex processes, even by non-engineers and non-programmers. So the Python community has developed this function syntax or function-based syntax so that non-programming guy and non-engineering people also can run these functions. Now the function name looks very simple, but backend there is a complex programming code which is written by the Python programmers. So the Python programmers write the complex codes behind and store it in the name of a function. They write the Python programming code, and that programming code will be stored in a function, and we use those functions in our data analysis. So if you look at the function syntax, the function syntax is either library name dot function name with parenthesis, or data frame name, whatever data name you are giving while importing data, whatever name you are giving, that with the function name followed by parenthesis. Every function in Python is lowercase and must have parenthesis or round brackets. Either parenthesis will be null, or arguments will be given in parenthesis. So the functions are very important in Python. As part of data scientist and data analyst, we will use these predefined functions. There are lots and lots of predefined functions. Thousands of them are there for various activities and purposes. Okay, and we use these predefined functions. All the predefined functions like head, tail, shape, d types, they're all predefined functions in Python. We are using them to analyze the data. Our job will be data scientist or data analyst. There is another set of thing called data programmers who study Python programming plus Java programming. The core programming of Python is Java. So there will be programmers, data programmers who will be specialized in Python programming, who will be specialized in Java programming, and C and C++. C, C++, Java are compulsory for Python programmers along with Python programming. Okay, so programmers are different. We will be using the functions created by those programmers and stored in these libraries. The community constantly updates these libraries with various functions that are required. So for various purposes, whatever functions we are requiring, those will be updated by the community into these libraries. So this is the basic introduction of the Python libraries and function syntax. Now, all your doubts are clear? So the function syntax is library name dot. So to every time instead of using pandas, we will use PD. So you need to remember some basic functions. If you can't remember, you have to go to documentation and type the what you need. It will suggest the function. There are many functions. So you need to constantly practice and you need to remember those function names. Okay. Now participants, import the libraries. Import pandas as PD. Import numpy as NP. Import matplotlib dot pyplot as PLT. Percentage matplotlib inline. So every time you start a Python project, you have to import these libraries. Without importing these libraries, you cannot work. So first import the libraries so that you can use the functions predefined in those libraries for our work. Then we will set up our working directory. So we will set up the working directory for easy data import. Import IO. IO is a input output library which is in base Python. %CD. Windows laptops is double quotes. Windows laptop double quotes, Mac guys single quotes. So my data for my data is in datasets folder. Where is the data? Melbourne data. So I'll copy the path. Paste it. Then we will get the data set. So housing is equal to PD is the library name. The function is read underscore CSV with parentheses, double quotes, and argument melb.csv. Now all the participants, once you have imported, run these functions: head, tail, shape, dtypes, columns. Once you're done, please confirm. Okay. refer the old notebooks. Okay, you can keep your old notebooks open and refer the function name. Participants, you can confirm in chat box also that you have done. రామకృష్ణ, గుడ్ మార్నింగ్. నాకు 2 క్వశ్చన్ పేపర్స్ పంపించారు, దాన్ని కీ పంపించలే. ఫైనాన్షియల్ మేనేజ్మెంట్ నేను చెప్పలేదు కదా కోర్సు, అది కీ రాలేదండి నాకు. క్వశ్చన్ పేపర్సే వచ్చినాయి 2. కొద్దిగా చూసి నాకు కీ పంపిస్తే నేను చేసి ఇమీడియట్గా పంపించేస్తాను. ఓకే, రైట్. గుడ్ మార్నింగ్ సార్, ఉదయ్ గారు. ఇది సండే మీరు ఏదో ప్రోగ్రామ్ పెడతా అన్నారు. నాకు సండే 8 to 10 మార్నింగ్ బిట్స్ పిలాని క్లాస్ ఉందండి. మరి మీరు ఆఫ్లైన్ కావాలా, ఆన్లైన్ కావాలా? అది నేను వస్తాను. నేను 11కి రమ్మంటే నేను వస్తాను. క్లాస్ కంప్లీట్ చేసుకుని ఒక ముందే, ఒక పావు గంట ముందే నేను 10కి బయలుదేరి 11 కల్లా వస్తాను. 11 to 1 చెప్తాను నేను మరి. ఓకేనా? ఓకేనా? ఏదండి? అదే మీరు ఆఫ్లైన్ అన్నారు కాబట్టి చెప్తున్నాను. 8 to 10 నాకు బిట్స్ క్లాస్ ఉంది, బిట్స్ పిలాని క్లాసు. అది అవ్వగానే నేను బయలుదేరి 11కి వస్తాను అంటున్నాను. ఓకేనా? So for finding missing values, you have to use data frame dot is null. The function to identify missing values is null. Then you sum up the missing values dot sum. Then you sort them in descending order. Sort values ascending is equal to false. So is null is a function to identify the missing values. Dot sum is to total the missing values. Then sort underscore values is to bring the sorting to descending order. By default is ascending. So which columns has missing values?
Building area,
Building area, year built, council area, car park is there or not? So participants, tell me what should we do with these missing values? Analyze these three missing values. First, analyze building area, what type of variable it is, and then suggest me the solution, participants. So participants, can you confirm you have done till the point of checking the missing values? Can participants confirm either on the chat box or orally?
Yes, sir. Yes, sir.
Okay. So let us understand the variable building area. B capital. Average is 151, 126 is median. Maximum building area is 44,515. So what should we do? Participants, what should we do?
Fill it with mean, sir.
we'll fill it with mean. Okay, good. So building area is being imputed with mean, right? So how do we impute? Housing data dot building area is equal to housing data dot building area dot, the function is fill NA. Fill NA housing data dot building area dot mean. So fill NA is a function to fill the NA, and in that fill NA function, we are giving the mean, building area dot mean as the thing. Then I will run the previous command, describe again. Now I got 13,580 observations. Hey, what is the shape? 13,580. Is the shape 13,580 participants? I didn't print the shape.
21, sir.
Housing data dot shape. 13,580, na? Rows I am talking about. Because the count is rows, right?
Yes.
Earlier it was 7,130 something. Rohit, this is a numeric variable, na? Rohit, this is a numeric variable, right? For numeric variable, we can either use mean or median. But the participant, you guys have decided we'll do it with mean. So I have done it with mean. It's a numeric variable, right?
Yes, sir.
So mean or median, your choice. People said mean, so I have imputed with mean. So I'll go back and see the null values are gone. Now year built. Now year built cannot be treated as numeric because years are dates, I told you, na? You can't treat them as numerics. You have to see, oh, there are many years. 1897, 1898. Most of them are built in 1970. So year built, you can see here, most of the houses are built in 1970, 866, 725. So what should we do? We have missing values. How many missing values are there? 5,375 are there. So what should we do here? What should we do, participants?
So we can check the percentage and based on that we can.
Okay, you're saying we'll do a frequency distribution and do it. How do we check the percentage? See, actually percentage is very high. So the percentage is very high. So if you look at it, 5375 divided by 13,580, right? So we have 40% missing values. What should we do? Because we can't add it to an existing year, right?
Yes, sir. We can put missing.
So what we will do is we will impute with a numeric missing code. Like how we use the word, right? This is numeric data, right?
Mhm.
So we will create a numeric missing code like 9999. Okay. So 999 indicates to me that it's a missing value because the data is in missing value, right? It's 9999.0. Or you can use any number except these numbers which are there in the data. We will not have 999, right? So we can't use the word missing here because this is numeric, what you call, this is what we call it as integer type. So we have to create a numeric missing code. Numeric missing code like you can create a line 999.0. That tells me that it is a missing value. And I could not impute it because we are not in a position to decide which year it belongs to. So we will impute it just like how we imputed earlier with the word missing. Here we will impute with the word with the numeric 999.0. Okay. So housing data dot year built is equal to housing data dot year built dot fill NA 9999.0. So we are imputing with the word with the numeric 999.0 because we are not sure what to do with it. As we are not sure, we are just creating a missing code. Got it, participants, all of you? There we were using the word missing. If it is text data, we will use the word missing. If it is numeric data, we will create a missing code like 4 nines or three nines, something like we'll create it, which is not, the number should not existing in your should not be existing in your data. That is the only criteria. Got it, participants? Any doubts, guys?
Got it, sir.
Yeah. Now housing data dot council area dot value underscore counts. So council area, moorland, we have these areas which are there. These are the all council areas. How many missing values are there? 1369. Oh, again, we have the same issue. We have too many missing values, right? So we can't add it to the existing variables because the highest is 1163. So we have too many missing values. So we will impute with the word missing. So since there are many NAs, cannot be added to existing segments, we will impute with word missing. We will impute with the word missing. So housing data dot council area is equal to housing data dot council area dot fill NA So we will add it that will become a larger category, missing values. So we don't know. So we can't impute it. So we are imputing with the word missing. So car also we have missing values. Let me just go and run the command again so that the missing values goes off. So 62 cars, 62 are missing values. So we can impute it with the word with 62 as two cars. Or we can impute it with one car also. What will impute with two cars or one car?
Two.
Two is better, right? Okay. Housing data dot car is equal to housing data dot car dot fill NA 2.0. And I'll go up and run the missing values again, and there are those 0 missing values. So we have imputed all the missing values. Create histogram, box plot, and density curve of price, and do the interpretation. Also do the describe first. Describe of price and then create histogram, box plot, density curve of price. Participants, how many of you are done?
Done, sir.
Done, sir.
So housing data dot price dot describe. Oh, all of you got the numbers like this, huh? These are very large numbers, right? So we have to round off. NP dot round, comma 4. Yeah, 2 decimals it is working. So minimum price is 85,000. Maximum price is 9 million or 90 million. 90 million. Huge. Yeah, 90 million. So housing data dot price dot plot kind is equal to hist. What is this? What skewness we had? This is what skewness?
Positive.
Positive skewness. Yes. So housing data dot price dot plot kind is equal to box comma what is equal to false. So we have outliers on the maximum side and the box is onto the left side. So clearly positive skewness and outliers. Housing data dot price dot plot kind is equal to density. We have a narrow tall peak, positive kurtosis. Find the skewness and kurtosis, actual values, and paste them in the chat box. Ashish has pressed this. Skewness is 2.23, kurtosis is 9.87. Very high skewness and kurtosis. So, print housing data dot price dot skew. Print housing data dot price dot cut. 2.3 and 9.87. Very high positive skewness both. Can we correct the price skewness? And p dot log yeah, it is bringing to somewhat close to normal distribution log. Logarithmic transformation, right? Participants, you remember? Positive skewness, what we use? Logarithmic. See, it's moving the box to the middle and giving you outliers on both ends. So log is working here. We can do logarithmic transformation, right? Agreed? Because positive skewness, na? Check the pre-processing notes here. So what is this? You can see here. Got it? Positive skewness, logarithmic transformation. That's why I've used np.log. All the participants got this? So frequency counts of variable rooms, type, and method. Notice participants, frequency counts of rooms, type, and method. Done, participants, all of you?
Yes, sir.
So 1, 2, 3, 4, 5, 6, 7, and 10 rooms. HUT. Method is property sold prior, property passed, sold prior and all. Type is bedrooms, house, cottage, unit, townhouse. So this is the last data. Oh, full CSV data is also there, 5.2 MB, 5.2 MB. All right. All of you got this? What is the average price for different council area? What is the average price for different method? What is the average price for different rooms? What is the average price for different types? What is the average building area for different council area? Please answer these questions, all of you.